Section 2.4 Properties of Quadratic Functions, Part 2. Let's take a look at the standard form of a quadratic function. And that looks like this. F of x equals a times x minus h quantity squared plus k. Now, the nice thing about writing our quadratic function in this form is that we can easily see the vertex of our parabola, which is hk, and the axis of symmetry. And I'm going to go up here. This was from the last video. So if we look at the axis of symmetry, it is right, the line passes right where the vertex is at. And so here is our vertex. All we have to do is look at the x coordinate, and our line passes through that point. So our line, the equation of our line for our axis of symmetry is x equals h. Now the parabola, whether the parabola opens up or down, all we have to do is look at whether our leading coefficient is positive or negative. And we knew that from section 1.5. For example, let's say we have negative 3x squared. In 1.5, we talked about how if there is a negative, we know that our parabola is symmetric with respect to the x-axis. So instead of looking like this, just like y equals x squared looks like, we now have something like this where it reflects about the x-axis. So if a is greater than 0, our parabola opens up, and if a is less than 0, our parabola opens down. And we're going to use these things to sketch our graph. Now, we already sketched this graph in the first part of my video, and it's up here, and we did it using transformations. But now we're going to use these other new terms that we learned in this section. Let's go ahead and do that. Okay. So the first thing I want to do is I'm going to look for the vertex. Now, because this is already in standard form, I don't have to do much work. You'll see that in the next examples we will, but not for now. So we have y equals x plus 3 squared minus 1. Now, notice that in our standard form, we actually have x minus h. So this in standard form would be x minus negative 3, since negative times a negative is a positive, plus negative 1. Now, I'm not always going to write it like that. I just want you to see that our h is actually negative 3, not positive 3. And our k is negative 1. Okay. So we have that the vertex is negative 3, negative 1. I'm going to box that because it'll be easier for me to find when I need it. The next thing I'm going to look for is the axis of symmetry. And that one's fairly easy since we already found the vertex. And the axis of symmetry is a line, so it has to be an equation of a line, and it passes through our vertex. So I know it's x equals 3. Next, we want to look at whether our parabola opens up or down. And our parabola opens up. And I know that because our a is positive 1. Finally, I'm going to look at one more thing, and that's my intercepts. This will help me see where the parabola crosses the x and the y-axis. So just a little refresher, x-intercepts are where y equals 0. So we're going to set our quadratic equation equal to 0, and we're going to solve for y. So add 1 to both sides. And in order to get rid of the square, I'm going to square root both sides, but remember that whenever you square root, when you take the square root, you have to write plus or minus. So we get plus or minus 1 is equal to x plus 3. So we get two different answers. We get x plus 3 equals 1 or x plus 3 equals negative 1. And we get x equals, if you subtract 3 from 1, you get negative 2. And if you subtract 3 from negative 1, you get negative 4. So we have two intercepts. And you know that I always have you write your intercepts as points because they are points. Okay. And then the y-intercept, that one's always the easier one. You just want to set x equal to 0. So we have y is equal to 0 plus 3 squared minus 1. And if we simplify that, we get 8. And again, I do like writing this as a point. And you should write it as a point because it is a point. So now that we have all our information, we're ready to graph it. And I'm going to just go in order. So we have the vertex is negative 3, negative 1. And notice that on my y-axis, I went by 2 just because I don't have all that much space. So I have negative 3, negative 1. So negative 1 is about here. Okay. And then my axis of symmetry just goes through the vertex. And that's x equals negative 3. My parabola opens up, but we'll use that later once we actually draw it. Our x-intercepts are negative 2, 0 and negative 4, 0. And my y-intercept is 0, 8. And now I just draw my parabola. So there you have it. Now, since this is symmetric, about the line, about the axis of symmetry, I just want to point out, see how I'm 3 units away from my axis of symmetry. I'm also 3 units away from my axis of symmetry in the other side. And that's why we need that to graph. And it looks exactly the same as the graph I had in example 1 because it is the same graph. And I just wanted to show you what it would look like using the other information.